Okay, for this lab, we're going to talk about logic apps again, but this time integrating with Azure Functions. And the emphasis here on this presentation is about serverless code in Azure. So way back in the old days, when enterprises needed to run their systems, they built their own data centers, basically a server room where they housed all of their equipment on premises, or maybe they had a vendor like SciTech or something like that host their servers for them. But the servers were all under control of that organization. They had to provision them, they had to buy them, they had to set them up, and they had to maintain them. And then build all of your own security around that. And not only security, but also high availability. So if they wanted to make sure that they could withstand a disaster, they might have 2 data centers, for example, and manage all the servers for that. And the thing with that was that if they had certain periods of the year where you expected very high traffic, you had to provision enough equipment to handle all of that traffic, even if the 90% of the rest of the time they weren't used. So it was an expensive proposition to be able to maintain all of your equipment. So then with the rise of the cloud about 10 years ago, I guess, came the concept of infrastructure as a service, which is basically like rent a server. And the server is actually managed or hosted for you someplace else that you don't know about or care about, except maybe that you have some governance over the region, the geographical region that it's in. And with these servers, they were very highly redundant because there would be like 3 copies of everything, and the movement from one physical machine to another was something that was completely transparent to you. So as far as you knew, you just had a server that was running nearly 100% of the time. You could count on that. So that was great, except the only drawback with that is that even though you didn't have to provision the servers yourself and buy them and stuff, you did have to look after the system. So you were responsible for the operating system, for all the applications that were loaded on it, for patching them, all of that stuff, right? But it does give you tremendous control over doing customized server configuration, right? So then moving beyond that, you have PaaS. So this is saying, rather than rent a server, it's like rent a platform. I just want some place to host my website, right? Obviously, it takes a server to do that, but you don't care about the server. You don't really need to configure things about the server. What you need is you need that web application running, or that mobile application, or that bit of code. Even, things like web roles and worker roles. So I just need this code running in an environment where it will function. So that's basically PaaS. That was a step where it was less management and stuff to worry about. It was more focused on the application. So now we move into the last area, which is serverless. Okay, and in here, this is the case where it's a question of just give me the app. Like, I don't even want to know about the server or the provisioning of anything that has to host it. I just want this code to run, and I only want it there when I need it. So I don't want to have to pay for some machine somewhere to be hosting it. I just want to pay for it when I use it. And that's the concept of serverless. So just looking at what that is, obviously serverless is a bit of, I wouldn't say a misnomer, but it's obviously everything has to live on a server somewhere, right? But it's completely abstracted away from you so that you don't need to worry about it. There is never a machine that you can go and look at because it's completely managed, invisible to you by Microsoft. And the thing about it is that it's there when you need it, and there's no concept of worrying about scaling. Scaling will happen automatically for you as it's used. If you start getting more and more traffic to it, it will scale automatically. It's not something that you need to configure or provision yourself. And because it only works when you need it, you pay only for when you actually use it. So you don't have to pay for the provision of an app service plan, for example, which costs so many dollars per month to have those servers available. It's just as you use the app, you pay for it. So the benefits of that, it's less work and maintenance for you because you don't have to configure anything that's related to the service. You just literally configure that application, which would be a logic app or an Azure function. There's no management associated with that. Again, you don't have to configure things about scaling. It will scale automatically as you need it based on the demand. And you pay per execution of that service or that bit of code. So is that actually a benefit? In most cases, yes. but you have to be conscious of how much you're going to use it, right? So, for example, if you're running a logic app that has 5 actions in it, you pay per action, not just for the logic app, but actually each segment that goes through you pay for. So if your logic app does a loop, then every time it goes through that loop, every shape in that loop is costing money, right? Or if you have it on a recurring schedule and every 30 seconds it runs, well, every time it runs, you're paying for that trigger, regardless of whether or not it actually winds up proceeding through the logic app or not. Now, you're talking about minute fractions of a cent, right? If your app runs 10,000 times a month, that's probably not such a big deal. But if it runs 10 million times a day, then it starts to add up. So you need to have some thought about that, because if that's the case, it's not really an economical model for you to host that way, and you might instead go for the option to host it in an app service plan, which I believe is still available to you today. You can choose that option. So something to think about. So again, just reiterating about what we mean by serverless in terms of logic apps and functions. You don't have to worry about the VMs. You don't have to worry about the resources. It's actually mostly event triggered. So it's all about really responding to those events. You don't have the DevOps nightmares of, looking after the platform itself. And of course you pay per use. Another feature about these things is that they tend to always be created in the cloud. So you can develop logic apps in Visual Studio, and I think you can develop functions in Visual Studio. Is that right? You can. So you can choose to do that, but you don't have to. You can develop these all inside your browser as well, but still have continuous integration and stuff for connections through GitHub and stuff. So these two things, how do they compare, and when would you use what? So a logic app, as you can see, is kind of a workflow-based type of thing, so you can use that to visually design those workflows and run them. Whereas functions are really more about, I want to execute this arbitrary bit of code on something. And that code can be written in a number of languages. Right now it supports C#, F#, Node.js, PHP, PowerShell, Python, Bash, and Batch. When it first came out, I think it was only C# and Node that it supported. If you're in the microservices type of architecture, you would implement those microservices in Azure Functions, discrete pieces of code that perform a single function. But your logic app could then be used to orchestrate the process of executing those services. The logic app, in terms of an integration perspective, we talked about the connectors and all the different systems that you can connect to with that, so that provides that capability as well as hybrid connectivity. Whereas the Azure Functions also has integration capabilities with a limited set of inputs and outputs. I'll show you what that looks like very shortly. And of course, logic apps have the ability to host B2B integrations with EDI and AS2, and the functions are really just giving you synchronous and asynchronous execution. So this is another view of all of the connectors, or most of the connectors that are available right now for use with logic apps. This diagram is a little bit prettier than the one that I've shown. It was some of these slides were put together by Paco de la Cruz. He's our Mexican colleague down in Melbourne, who's probably giving this presentation right now at the same time. So you use the logic apps for connecting, for integration, and you can use Azure Functions pretty much for, and API apps as well for executing everything else, which is your custom code that you have to write, code that's not available to you just by interfacing with another system or service. So creating a function in Azure is quite easy. You ask for a new function, you fill out a few items. It's very, very standard, just like all the other artifacts you've been creating, like logic apps. You assign the typical things like your resource group and your subscription, give it a name and a location. Then you get a screen like this, which allows you to choose a language and to choose a particular scenario that you want. So there are different kinds of triggers for your Azure Functions. You can have it scheduled on the timer. You can have it based on data processing, which is usually like an event-based trigger, or you can have like a webhook API that you basically get something that calls into it to execute that function. And there are all kinds of existing templates too. There are actually 30 of them at the moment. You can only see a few of them here. Basically in different kinds of languages, and also what the triggers and the outputs are. So that would come pre-configured for you if you chose a template. You can also just choose an empty function as well and configure it all yourself. So From the develop side, once you provision it, you get a lot of plumbing code that's given to you out of the box. Like, for example, in this particular one, which is I think this was a web API, all of that code just is given for you to start with. So they give you a sample of how it works, and then you can modify it accordingly. So you get parameters that are passed in. All of them include a trace writer so that you can have output. You can basically log into your console what's happening. And all you really need to worry about is writing the code. So the plumbing is already done for you. If you need to integrate that function, you've got a screen that basically allows you to select a trigger. You can define additional inputs. For example, if you need to enrich something and you need another input as well. And you could have multiple outputs for your function. And the really cool thing is that when you choose a trigger and you choose a type, this will inspect your resource group and basically pull up whatever it finds that's available. So if you want to connect to a service bus queue, for example, it will populate for you in that Dropbox, and by selecting it, it will automatically get the connection string and everything, so you don't actually have to go through and manually put that stuff in. And the same thing for the outputs. It works the same way. So speaking about inputs and outputs and triggers, what's available right now? This is growing all the time, this list. But at least at the time that this slide was made, and it might have changed in the last few days, the first column shows you what triggers are, and then also what inputs there are. So you can see how you can respond to things like events, like, for example, rows being created in tables or documents arriving, and then outputs as well, so you can output to Twilio or SendGrid emails. There's also the ability to test the function. Again, all of this is done right in your browser, so you don't need Visual Studio or anything to develop this. You can run your code. It gives you a sample input that you can modify. You click run and you get an output, and then a console that shows all the tracing that you've put into your code. From the management perspective, you can set up things like continuous integration. You can define access settings, things like CORS, for example, and your authentication and authorization. In this particular screenshot, I opened up a function that I'd created over a year ago, and it told me that it wasn't at the latest version. So just basically click that update button and it automatically updated to the current version for Azure Functions. So what are some of the scenarios that functions are good for? Well, you can use the scheduler so that with basically a cron job syntax, you can define your function to run at certain intervals and do things like, for example, you might use it to clean up a database table, to run every period of time and get rid of old rows. You can respond to all kinds of events. So an example here is a file arrives in a blob. You can pull that file out. If it's specifically maybe an Excel file and you want to break it down and load the data into a table somewhere in SQL, you can do that. So you basically have serverless web application architectures. So you can define a web page that has a webhook into a function and then does some processing. For example, you might use a function to choose a specific ad to show a user on the page and targeting something specific about, like, where are they accessing it from, for example. And of course, SAS event processing. So with connections to things like OneDrive and stuff, you can generate connections based on the arrival of a file. Stream processing is another use. So using stream analytics, you can basically feed that into an Azure function to do processing on that data as it comes through. Again, all of these models are based on the fact that you pay for what you use, right? You only pay when the code is executed, so it's perfect for an event-based type of architecture. Same thing with bot messaging. So this is yet another diagram that Paco has written. Is much more colorful than the other one. And it just shows again how all of this stuff relates to bring you hybrid integration. At the center of things, you can see logic apps which could be used to orchestrate your services and make use of the connectors so that you can avail yourselves of all of those SAS and Azure services that are available. On the side of that, you can use it to call out the functions or API apps if you need some custom code performed, and use Service Bus when you need to have that sort of loosely connected architecture with queues and topics. And then sitting on top of everything is API management, which controls your access to everything. So with that, are there any questions? Great. Okay, so for lab number 4, basically you're going to work again with logic apps, but what you're going to use is the logic app is going to invoke an Azure function to perform some logic, and you're also going to send data to Azure storage as well. So the prerequisites for this, nothing I think that you don't have already. Azure Storage Explorer and Postman, they're both in those files that you copied from the USB, so there's no need to download those.
Do you want to mention the code library as well?
Yes. Previously with Azure Functions, you'd compile them into a CSX file, but now you can actually provision them as a web app by putting, it's a manual process at the moment, but you put a few artifacts into your web application and you compile that as a library that you have a code library that's available for you to call. So you can publish it as a web app. Something else too that's been made public but is not being publicly announced yet is that there is now integration with App Insights for Azure Functions. It's in preview mode at the moment. So you can get real-time tracing. One of the artifacts that you'll need, again, that's in that folder, is a CSV file. This is the customer data that you're going to use to import into an Azure storage table. So effectively what you're going to do in this lab is you're going to create a service that receives orders from a service bus topic. Or if you don't want to use the service bus, if you didn't finish that last lab, you can also invoke it manually. We'll have a condition that based on the total amount of the invoice, whether or not it's over, say, $50,000, you'll create a task for sales employees to contact the customer to verify the order. And in other cases, it'll just process the order with a function and check a storage table to determine what the discount rate should be, and then ultimately save a copy it into blob storage.